So we now start with the next chapter for maths, that is sets, operation on sets and Venn diagram. So we'll just recap what the set means. So set is a group of well-defined articles. So when some well-defined articles are going to be there, then that particular group of that well-defined articles will be called as a set. Like when I say the group of the natural numbers, so it will be, we can say the set will be natural numbers will start with 1, 2, 3, 4 to infinity. So this is how we write as a set. If you set the set of odd numbers, so it will be 1, 3, 5, 7 and so on. So that will be odd numbers. It could be set of vowels. So we have that it will be A, E, I, O, U. So these will be the set of vowels. So this way you can define the sets. Now the way I'm writing this over here is called as Rooster form, or it is the one in which you are writing each and element of that particular set separately. So when you are writing or the different names, so that is called as the Rooster form of a set. There is another way of writing the set, and that is called a set builder form, which is in the form of a formula. So like for example over here, we can just write A is equals to, we can write as all natural numbers, and you can put it over here. So this can be just an example. So now we see the operations of sets. So in the operations of set, the first thing what you are having is union. So first one is union. What is a union? Union is going to be indicated or symbolized as U. So it will be A union B, written like this. Let's take an example. Let's say A is a set of alphabets A, B, C, D, E, F, and B is a set of vowels A, E, I, O, U. In this case, the union of these two will be A union B will be equal to all the values of A plus all the values of B, but without any repetitions. So that's why A will be coming, B is not here but it is here, so B, C, D, E is in both of them, so it will be coming only once, then F, then it will be I, O and U. So we can see all the values of A and all the values of B are present in the A union B. So A union B is nothing but the union, that is the combination of the two sets such that it has got all the values of A and all the values of B in it. So that is A union B. The next one we see is intersection. Intersection is denoted by inverted U. So it is always A intersection B written this way. A intersection B is written this way. Now intersection is intersection. We know what intersection means. Intersection means something which is connecting the two. Okay, if this A and B are two sets, the one which is connecting the two is the intersection between the two. So connecting means what? The one which are common between both the sets. Those elements which are there in A as well as in B are the answer for A intersection B. So we see that A intersection B will be over here. You can see A is common, so A will be there. B is not here but not here, C is here but not here, D is here but not here, E is here as well as here. So E will be there, F is not here, I is not here, O is not here, U is not here. So the answer is just AE. So this gives us intersection of two sets. So intersection of two sets will be all the common values between two sets. If two sets has anything common between them, it will be coming under the answer for intersection. But if at all it so happens that suppose A is 1, 2, 3, 4 and B is, let's say, 5, 6, 7, 8, then A intersection B, first of all let's take union also. Union will be 1, 2, 3, 4, 5, 6, 7, 8. But A intersection B over here is nothing, which is written as null set either this way or it is written as 5, which is like this. 0 ke upar aisa slash. This is the symbol for null set. So null set is the one which is going to be having no elements in them. Right? Now, so this was about union and intersection. Now we see about difference of the two sets. So we see the next one. Difference of the two sets. The difference of the two sets can be given as A minus B or B minus A. Okay, this could be two differences. So when it is A minus B, we'll be having it this way, that A minus B will be equal to whatever is there in A, which is there in B also, will get cancelled. So you can see A is here. If I subtract this from here, then A will get cancelled, E will get cancelled. So whatever is remaining over here is A minus B. You are not going to see any other numbers over here. The answer will not have anything from B. It will have only values from A. A minus B will have values only from A and also those values which are not present in B. So A minus B is all the values of A which are not present in B. So we can see that A, B, C, D may say A was present in B, E was present in B. That's why the answer is only B, C, D, F. Got it? That is A minus B. So similarly, what will be B minus A? All the values of B which are not in A. So you can see of the values of B over here. What are there in A? This is there in A, so it gets cancelled. E is there in A, so that gets cancelled. Whatever is remaining is the answer for B minus A. Hence, B minus A will be IOU. Understood? So, A minus B is all the values of A after you remove the points which are there in B also, or all the values of A which are not there in B. And B minus A will be all the values of B which are not there in A. So that's why we have got A minus B and B minus A. Now in case it so happens that let's take an example over here, that we have the value of A as 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And B is 2, 4, 6, 8, 0. In such a condition, A union B will be all the values over here. So it will be A itself. A intersection B will be equal to B itself. See this. A union B has all the values of this and all the values of this. This is already present over here. So all the values of A become A union B. A intersection B, you know that all the values of B are there in A. So those are the values which are going to be A intersection B. So A intersection B will be B. In case of A minus B, what will be A minus B? A minus B will be equal to 1, 3, 5, 7, 9. But what will be B minus A? B minus A will be null set. Why? Because all the values of B are present in A. Now when you have got such a kind of sets where all the values of A, all the values of B are in A, we call that B is a subset of A. Okay, we call it as a subset. So B is a subset of A. That means B has got those values which are already present in A, or A has got all the values of B present in it. That's called as a subset. And in such a condition, you can have something which can be a complement of B, which is given as B dash. So what is the complement of B? Complement of B will be all the values of A which are not there in B. So we will be having B dash will be equal to, if I see this one, what is complement of B? It will be having 1, 3, 5, 7, 9. Got it? So therefore, in such a case, complement will also be equal to A minus B. Right? This is just for your understanding. Normally you will not require to learn this thing, but yeah, you need to understand it properly, that when you are taking a complement, the complement will be equal to the main set minus the subset. That is A minus B will be the complement B dash. In many cases it happens that the A set, instead of an A set, there is something which is called as a universal set. A universal set will be the one which is a bigger set, which has got a lot of numbers in them. So universal set could be all natural numbers, all whole numbers, all integers, or maybe even 1 to 100, 1 to 50, 1 to 10 can be a universal set. So if universal set is given to you, the universal set is given by this particular kind of a symbol. Okay, something like a italic E, that is universal set. So universal set is given as this particular way, and in that case, suppose I have got a universal set. Universal set is given to me as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In that case, if A is given as 1, 3, 5, 7, 9, then A complement will be based on the universal set. So A complement will be what? All the values of the universal set which are not there in A. So that will be all the values. It is 0, 2, 4, 6, 8. That will be A complement. You'll always find that A union A dash will be equal to universal set. The union of A and its complement will always give you the universal set, and A intersection A dash will always be a null set. Because complement means what? Something which is not there in A. So automatically intersection will be null set, 0. So null set, that will be the thing for complement. Now when we talk about these sets, what we see over here is, let's take some example before we do the next one. So let's take the original example what we had. So we have A is equals to A, B, C, D, E and F. B is A, E, I, O, U. Now in this case, you can see there is something common between the two. There is an intersection possible. So such a kind of a thing where A intersection B is not equal to a null set and it is equals to A and E. That means there is something intersection between the two are called as overlapping sets. So those sets which has something common in them are called as overlapping sets. So those ones which are overlapping are the one in which the intersection is some value other than null set. Whereas if it is this way, A and A dash, is there anything common between the two? Nothing common between the two. So what are these called? Such kind of sets are called as disjoint sets. Okay, they are disjoint sets. So the one in which A intersection A dash is equals to null, then such a set is called as a disjoint set. So non-overlapping sets are disjoint sets. So when the overlapping area is null, okay, if there is nothing common between the two sets, we call it as a disjoint set. So that's why we have got two kinds of this thing, which will be overlapping sets or disjoint sets. We then see some kind of laws which are present over here. So we will just see those laws first. In fact, you can now note down certain important results and laws so that it is very easier for you to solve the exercise. Okay, so we see one by one the things. Okay, we have first one as, I don't think that is required. A union null set is equals to A union universal set is universal set. Okay, and A union A is A, of course. So there is nothing unique over here. Okay, one is, second thing is, it is, the sets are commutative. What does mean by commutative? A into B likho or B into A likho, it's one and the same. So whether it is A union B is equals to B union A. Similarly, A intersection B is equals to B intersection A. So whether I change the order in which I am writing, it is going to remain the same, but it is not the same for A minus B and B minus A. A minus B and B minus A are not commutative. They are different. So that is one part. Second part over here is A is a subset. So third thing is A is a subset. This is the formula for subset. Subset is, I told you that it is the one which is a part of a main. So A is a subset of A union B. Obviously, A is a subset of A union B. Similarly, B is a subset of A union B. Okay, and so of course A union B will be the subset of A union B will be the subset of the universal set. Okay, so that's one part. What else? Yeah, the next one will be A intersection B is a subset of A, and A intersection B is a subset of B also. But these are not so important, not so required, so you may skip this part. Okay, and finally is De Moivre's law. The fifth one is A union B dash is equals to A dash intersection B dash. Now this is important. Okay, this is important. A union B dash is equals to A dash intersection B dash, and A intersection B the whole dash is equals to A dash union B dash. Okay, this is important. So this part is important. You need to learn this part. May be helpful in some of the questions. Otherwise, these are quite logical, so you don't require to learn them. It's quite understood. But here, this is a law sort of thing, that A union B the whole dash. That will be A dash intersection B dash. Okay, that is De Morgan's law. And if A and B are two sets, then A and B are disjoint, then A union B will be null set, A intersection B will be null set, and they're overlapping, the A intersection will be not a null set, so not something important. But now we come to the very important formulas over here, and these are about the cardinal number. So first of all, let us understand what is cardinal number. So next thing is, if A is given as A, B, C, D, E, F, then I can write this as NA, that is the cardinal number of set A is equals to 1, 2, 3, 4, 5, 6 is equals to 6. So what is the cardinal number? Cardinal number of a set tells you that what is the number of elements or how many elements are present in that particular set. So the number of elements present in the set gives the cardinal number of that particular set. So cardinal number is very important. So if I am saying B is equals to over here A, E, I, O, U, then we say NB is equals to 5, because 1, 2, 3, 4, 5. Okay. So cardinal number gives you the number of elements present in a particular set. Accordingly, you have got certain very important formula which are going to be used for the cardinal number, and these are very important because they are especially important in case of Venn diagram and the calculations what we do in the Venn diagram. So we have got the following things. So the first one is NA. Okay, I'll take the whole board because some things are required to be long ones. So NA union B, that is the number of the elements in A and B, will be equal to N of A plus N of B minus N of A intersection B. Try to understand this. If A has got, let's take an example. A has got A, B, C, D, E, F. So NA is equals to 6. B has got A, E, I, O, U. So NAB is equals to 5. So NA union B. A union B will be having all the numbers, that is A, B, C, D, E, F, and then I, O, U. So NA union B will be equal to 6, 7, 8, 9. Whereas N intersection B will be A and E. That is NA intersection B will be equal to 2. So you can see over here, NA union B will be, पहले हमने क्या किया, इसको और इसको add किया, so that is 6 plus 5, that is 11. But then what happens? Those numbers which are repeating has to be cancelled. Which are the two numbers? That is nothing but this. So that's why I am subtracting 2 from here to give me 9. You can see this is 9. A union B is 9. So that's why A union B is equal to NA plus NB minus NA intersection B. Very, very important formula. You'll use it a lot of times, especially in the Venn diagram. So that's the first formula. NA union B is equal to NA plus NB minus NA intersection B. NA minus B is equal to NA union B minus NB. It is also equal to NA minus NA intersection B. Similarly, third one, NB minus A is equals to NA union B minus NA is equals to NB minus NA intersection B. The fourth one, NA union B is equals to NA minus B plus NB minus A plus NA intersection B. You rarely use this one, but yeah, you need to remember this. NA union B is NA minus B, B minus A, and if you add this up, you come to say same thing. Doesn't matter, don't need to understand that. Then finally over here is, if universal set is there, then NA plus NA dash is equals to N universal set. Okay, that is the last formula. So these are the formula. NA union B, maximum is going to be used as this one, very common, and the other one is this one, very common over here. That will be A and its complement will be universal set, and A union B will be NA plus NB minus NA intersection B. So these were the formula. We start with the exercise in the next video.